This is the video notes that are going to go with our guided notes for growth and exponential word problems. Now, our notes say growth and decay, but we're going to do growth in one video notes and decay in another video notes. I know that we've been taught, you've talked about growth and decay in science class as far as the spread of disease, especially during pandemics. You've also talked about decay when you talked about carbon dating, okay? But we're going to take a look at the actual formula for growth today and how we apply it to different types of real life situations, okay? Now, here is my first disclaimer. There are so many versions of this formula as far as sometimes what variables they are using, okay? If you Google it, you can probably come up with 10 different versions of this formula using different variables. But the formula still basically is always the same. They're just using different variables, okay, to represent each item. Now, let's go through our formula that we're going to use. And the one that I picked is the one that actually our state standards are using. And it says A, capital A is equal to capital P, parentheses 1 plus R, parentheses raised to the T power. Okay. This is the exponential growth formula. Now, what do all of these variables mean? Well, we've got them all defined right over here. A is going to be your final amount at the end of the problem, okay? It's going to be your final total. P, which is referred to as the principal, okay? The principal, and notice it's PAL, P-A-L, not principal like a school principal, okay? They're spelled differently. Remember, those are homonyms, two words that sound the same but have different spellings and different meanings. So this is principal pal, because your money is your friend, or the initial amount. What are you starting with? Okay, that's your principal. What is the very starting amount you have at the beginning? Okay, A is what the amount you have at the end. Okay, R is your percentage rate. Okay, if you're talking about banking, that actually might be your interest rate. Okay, it's your percent of increase or decrease. Now that's words you learned last year in math. Percentage of increase or decrease. Okay, that's your R. T is for time. Okay, this is going to occur over a certain time period. Okay, it might be minutes, it might be days, it might be weeks, it might be years. Okay, it will have a time unit on there. T is for that time. Okay, N is for how many times it is divided up. But you know what? That's all I'm going to say about N, because that's an entirely different lesson. We're going to focus on today is A, P, R, and T. Okay, so let's look at our first example right here. Okay, so let's read through this. The population of the United States has been increasing. Okay, increasing means growth, getting bigger, at an average annual rate of 0.91%. If the population was 284,905,400 in the year 2001, predict the population in year 2005. Okay, so we have a growth because it's saying increasing. So that means I'm going to use this formula right here. Now, what I'm going to do though is identify my variables. The P, that is our starting amount. So that is my 284,905,400. My R is my percentage rate of increase, the percent of increase, and we're told right here that it's 0.091%. But you guys, you got to change that to it's a decimal equivalent. So you know to get the decimal equivalent, you're going to move your decimal over 2 places. So what that really is 0.0091. Okay, that's the decimal amount I'm going to use. Okay, moving my decimal over 2 places. Okay, now let's talk about our T. This is the number of years. Okay, our time here is in years. Now look, it's asking us from 2001 to 2005. So how many years would that be? That would be 4 years. So this is my starting population. This is my percent of increase on the population. I'm really trying to find out after 4 years, what is my new population? So what I'm really looking for here is A. Okay. Now let's go ahead and let's use our formula. So let's write it down. A equals P parentheses 1 plus R, close that parentheses, to the T power. Okay, remember, anytime you use a formula, you always start off by writing the formula. Okay, that tells the person reading your work what it is that you're wanting to do. Now let's plug or substitute our numbers into the right place. So A equals 284,905,400, parentheses 1 plus the 0.0091, close that parentheses, and it's going to be to the 4th power. Now, y'all, after you get right here, grab your calculator, and you can just type it into any old calculator you want. So 284,905, 400, parentheses 1 plus 0.0091, close that parentheses, and I'm going to raise that to the 4th power. Now I get this old, like, woohoo, big old, you can't see it on the screen. There you go. This big old long decimal number. So let's write this down. And let's round it to the nearest person, because you don't want part of a person. So we've got 295,418,375, and put in my commas so I can read my number clearly. So at the end of 4 years, I should have 295,418,375 people in the United States. Okay, pause your video if you need to and go ahead and copy this down, and then we'll go to our next example. Okay, now our second example is the same type problem, but this time I'm actually not talking about population. I'm going to be talking about money. Okay, so if we read through our second example together, Joe invested $20,000 in a money market account that got 3% interest per year. How much money would Joe have in that account in 10 years? Okay, now again, I need to identify all my different variables in my formula. P is the starting amount. It says he invested 20,000, so that's how much he put in at the very beginning. Okay, R is your rate of increase, And even though it doesn't say rate of increase, it says he got 3% interest. He earned 3% interest. So that's giving it to him and adding it to his money. So that is an increase. So that's 3%, but you guys know we can't use 3%. We got to use 0.03 when you move that decimal over 2 places. Okay. And then we need to talk about time. Again, my unit of time here is years. But how many years is that? It says right here, 10. Okay. And it says, how much will he have in his account after 10 years? So what we're looking for is the A. Again, we're looking for A. So I'm going to write down my formula. A equals P parentheses 1 plus R close parentheses to the T power. Okay. So P was 20,000. And then that's 1 plus 0.03 raised to the 10th power. And I'm going to grab my calculator again right here, and we're just going to type this in. And I can type it just the way I see it, parentheses and all. And I'm going to take my answer right here. See if we can see it. And I notice it's got like 5 decimal places, but it's money. Money only goes to 2 decimal places. So I'm going to round it to the nearest penny. Okay. So when I round to the nearest penny, I'm going to have 2, 6, 8, 7, 8.33. And I want to put a little comma right there. So in 10 years, his money grew to where it was $26,878.33. Now, we're going to pause right here. This is part 1 of our notes for the growth problems. So make sure you've got these 2 copied down and put into your interactive notebook, and then you can go to Canvas and work on the growth word problem assignment.